Hello everyone. Today we will be discussing Leetcode question number 121, which is best time to buy and sell stocks. So this question is asked in Google about 24 times and Microsoft 13 times and Amazon 31 times in last 3 months. So let's read the question. What the question is. You are given an array prices where price I is the price of the given stock on the ith day. Okay, so you want to maximize your profit by choosing single day to buy one stock but, and choosing different day in the future to sell that stock. And you have to return the maximum profit that you can achieve from this transaction. If you cannot achieve any profit, return zero. So the question is saying that you have to create maximum profit. You can choose any stock one day and sell it another day in the future, and you have to create the maximum profit. Okay, so let's see the example. So example, it is given that 715364. So output is 5. How it is 5? It is 5. It is saying that buy on day 2 at price 1. Okay, so it has bought at price 1 and sell on day 5, which is price 6. So the profit is 6 minus 1, which is 5. So it has bought on this day and sold on this day, which is 6 minus 1. So the profit is 5. You can also check there is no other two pairs that can give you this much profit. Okay, so in the same way, let's say example two. Example two, it is 76431. The output is zero because in this case you don't have in any way you can't make a profit because because uh, because at the beginning the price are higher and at the end price are lower. So if you buy at higher price and so sell at lower price, then it will give you negative profit. So in that case, you can avoid doing any transaction. So if you don't do any transaction, your profit will be zero. So let's discuss the approach. So one of the brute force approach that come to the mind is that uh, you can simply run a double for loop and calculate the profit. Okay, so what you can do, you can start uh, in one loop, you can point to this, and in the inner loop, you can iterate all the other elements, and uh, and you can store the difference and maximize that. Okay, so if you're set at 7, then 1 minus 7, it will give you negative. So, so you can avoid negative, and in this way, you can compare with other what profit it is giving. So in this, again, you are having the negative profit, so profit can be zero. So and again it is 3, so you are buying at 7 and selling at 3. So it will give you a negative profit. So in the next iteration, you will be at this 1, and the inner loop will run from I plus 1 and here to here, and you will check if I will buy at this price and sell at this price, what my profit will be. My profit will be 5 minus 1, which is 4. So you can store it in the difference. Again, you can see it is giving you profit too, 3 minus 1, which is 2. So you are already having higher profit than you can audit. Again, the next element is 6. Then buying at 1 and selling at 6 will give you 6 minus 1, which is 5, which is higher. So you can replace this with the higher one. Okay, so this is the brute force approach, and the time complexity for this will be n square because you are running the two loop. So the interviewer will not be happy. So you need to optimize it. So let's see the optimized approach. Uh, in this approach, what we can do, uh, we can uh, we can have we can have the minimum. We will keep a variable to track the minimum. Okay, means I will traverse this array once, and I will keep tracking the minimum. Okay, so if I am at this index, currently my minimum will be the first index element, which is 7. And okay, so if I move to next index, so my minimum will be 1. Okay, so this is one scenario, means 1 point. Another is that we will have a result variable which will store our result. Okay, so our uh, our aim will be to maximize the profit. Okay, so we are tracking the minimum because we if I am at any index, and if I uh, if I want to if I want to make a higher profit, then obviously uh, I have to sell I have to sell if I have bought it at a lower price previously. That's why we are tracking the minimum. Means suppose if I am at index 5 and I have to think what profit I can make. So the larger profit that I can make is if I have the minimum element among the all previous element, which is 1. Okay. If I know which is the minimum among this, I can have the higher profit. Mm, because larger the difference, higher the profit. So if I have the minimum, which is 1, and if I am at 5 index 5, then I will have a profit of 5 minus 1. Okay, so in this way, I will keep traversing and tracking the minimum, and at the same time will calculate the profit also. Let's see how. So two variables we have, minimum and result. So initially minimum will be 7, and I will start with the index 1 because I have already taken the 0th element. So I will start with the one index, and initially our result will be 0. Okay, so I have minimum as 7, and I am at index one index which is having value 1. So if I sell at this index, then obviously I have a negative profit. Negative profit, then I won't sell. And I will, after that, what I will do, I will update my minimum. My minimum will be 1. Now I will move to the next index. Now at this index, I will check. I will not. I will. What I will do, I will assign my resultant as what? As maximum of max of result, and what profit I can make. If I'm at this index, the profit that I can make will be the element at this index, which is 5, minus the minimum which is 1, which is equal to 4. Okay, so 5 minus 1, which will give max of resultant initially is 0, so it will be 5 minus 1, 4. So resultant will be initialized with 4. Now I will update my minimum. Minimum, so current is 5 and initially minimum is 1. So previously minimum is 1. So minimum of 1 and 5 will be 1 only. So it will not be updated. Now moving to the next index. Next is 3. Next is 3. So again, we will assign result as maximum of result and the profit at current index. So the profit at current index will be current index value minus the minimum. So 3 minus 1, which is 2. So result is already max, so it won't update. It will move to next index. Again, profit at current index will be 6 minus the minimum. Before that, we will try to we will minimize this value. So it is 3 and it is 1. So it is already minimum. It won't update and it will move to the next index. Now at this index, the profit will be 6 minus minimum value, which is 1. So it is 5. So we can see that we got another maximum profit. So we will replace that with the highest profit and will minimize the minimum value. So current is 6 and minimum is 1. So it is already minimum, so it won't update. And we will move to the next index. So next index is 4. Next is 4. So current means profit at this index will be 4 minus minimum, which is 1, which is equal to 3. So our profit is already max, so it won't update. So in this way, we got our output as 5. Now let's see the code. Yes, so we are having a resultant variable and a minimum, and we are running the loop from 1, and we are maximizing our result with what? Max equal to rest of price at the current index minus minimum, as we discussed. And after that, we are minimizing our minimum value. So minimum of MN and price of the current index. And at the end, we are returning the result. So let's run our code. So it's passing all the given test case was submitted. Yeah, so it passed all the given test cases. Now time complexity for this code will be O of n, as we are running a single for loop, and space complexity will be O of 1, as we are not using any extra space. So yeah, thank you for watching. Do like, subscribe and share. Thank you.